Right now, somewhere far beyond the edge of our solar system, a machine older than most parents alive today is still awake. It runs on less power than the light bulb in your fridge. It sits so far away that if you sent it one single word right now, that word would take almost a full day just to reach it. And yet, this old machine is still listening. It is picking up something that no human being has ever heard before in the history of our species. This is the real story of Voyager 1, and where it stands today, in 2026, is stranger than anything its own builders ever imagined back when they first switched it on. Voyager 1 was launched in September of 1977. At the time, nobody thought it would matter this much, this long. The plan was simple: fly past Jupiter, fly past Saturn, take some pictures, send them home, and then quietly shut down after about 5 years. That was it. Nobody on the team believed this spacecraft would still be sending signals 50 years later. Nobody believed it would leave the solar system completely and keep going. But that is exactly what happened. And it happened because of a small window of luck that comes around only once every 175 years. During that window, several giant planets lined up on the same side of the sun at the same time. That lineup let engineers plan a path where each planet's gravity would throw the spacecraft forward to the next one, almost like a cosmic game of catch. They called this plan the Grand Tour. Something strange was already happening before the mission even properly began. Voyager 2 was launched first. But 16 days later, Voyager 1 launched on a faster path and quickly passed its twin. Just 13 days after leaving Earth, from more than 11 million kilometers away, Voyager 1 turned its camera backward and captured something nobody had ever captured before. It caught Earth and the Moon together in the same frame, floating in the dark. Our whole world looked like a tiny blue dot hanging in nothing. Even in its first 2 weeks of flight, this spacecraft was already changing how people saw their own planet. By the start of 1979, Voyager 1 reached Jupiter, and what it found broke almost every assumption scientists had made from telescopes back on Earth. Jupiter turned out to be a violent world, wrapped in storms bigger than entire planets, surrounded by deadly radiation, and circled by moons that behaved like their own tiny solar system. Then came Saturn and the flyby. They changed everything for the mission. Engineers made a choice that would decide the spacecraft's entire future. They sent Voyager 1 close past Titan, Saturn's biggest moon, to study its thick, strange atmosphere. That single decision came with a permanent price. Saturn's gravity bent Voyager 1's path so sharply that it could never visit another planet again. From that exact moment, Voyager 1 stopped being an explorer of planets and became something completely different. It became a machine with only one direction left, straight out, toward the edge of everything the sun touches. What most people don't know is that before any of this outer space drama happened, the team back on Earth made a decision that had nothing to do with science at all. They attached a golden record to the side of the spacecraft, about the size of a dinner plate. On it, they placed greetings, recorded in over 50 languages, natural sounds like wind and thunder, pictures of everyday life on Earth, and almost an hour and a half of music from different cultures around the world. The idea was almost too hopeful for a mission that was only supposed to last 5 years. The team hoped that one day, this record might drift close enough to another form of life and be understood. And even if that never happened, they believed sending it was still worth doing. That same golden disk has been riding along with Voyager 1 through every single moment of its journey since, quietly outlasting almost everything else the mission was originally built for. Nobody expected a small moon near Jupiter to become one of the biggest shocks of the entire mission. But that is exactly what happened, and it changed how scientists thought about life beyond Earth forever. Storms twisted across its surface that were bigger than our entire planet. Voyager 1 found faint rings around Jupiter that nobody even knew existed before. It also spotted several small moons that had never been seen or recorded. And then there was the Great Red Spot, that famous reddish smudge people had been staring at through backyard telescopes for centuries. Up close, scientists finally confirmed what it really was. A storm so massive it could swallow Earth whole, spinning endlessly, with no sign of slowing down. But the real surprise came from a much smaller world, a moon called Io. As Voyager 1 passed by, its cameras caught something nobody on Earth had ever witnessed before. Active volcanoes erupting in real time on a moon millions of kilometers away. Before this moment, most people assumed moons were just cold, dead rocks floating in space. Io proved that idea completely wrong. It was not dead, it was alive, boiling with energy underneath its surface. To this day, Io remains the most volcanically active place scientists have ever found anywhere in our solar system. Then, Voyager 1 passed another moon called Europa, and this one told a quieter but even stranger story. Its surface was covered in deep cracks, almost like a cracked eggshell. Scientists studying those images started to believe something was hiding underneath that icy shell. Not rock, not dust, water. A possible ocean sitting beneath kilometers of solid ice. This idea planted a seed that scientists are still chasing today. That the best place to search for life out there might not be a planet at all. It might be a frozen moon, quietly hiding a warm, wet secret underneath its surface. After Jupiter, Voyager 1, Heliopause. Voyager 1 used the planet's own gravity to launch itself forward, gaining more speed than any spacecraft before it, heading straight for Saturn. It arrived in 1980, and once again, everything people thought they understood turned out to be wrong. From Earth, Saturn looked like it had one simple, thin ring circling around it. Up close, that one ring exploded into hundreds, maybe thousands of thin, layered rings, constantly shifting and moving instead of staying still like everyone assumed. Voyager 1 also discovered new moons around Saturn, including one called Mimas, which had a crater so massive it looked almost like a tiny moon-sized battle station drifting silently through space. But out of everything Saturn had to offer, one moon mattered more than all the rest: Titan. Voyager 1 could not actually see Titan's surface because its atmosphere was too thick and hazy for cameras to see through. Still, by studying what that atmosphere was made of, scientists uncovered something incredible. Titan was so cold that methane, a gas here on Earth, behaved completely differently there. It could exist as a solid, a liquid, and a gas, all on the same world. That single discovery opened up a brand new idea, that Titan might have lakes, rivers, and weather just like Earth, except made of methane instead of water. Getting close to Titan came with a heavy price, though. Saturn's gravity pulled Voyager 1's path so far off course that it could never visit another planet again. From that point forward, its future was already decided. There was no turning back and no new destination waiting ahead. Just one long, quiet journey outward, heading straight toward a boundary nobody had ever reached before, and toward a moment in 2012 that would change everything. Scientists thought they understood about where our solar system actually ends. On August 25th, 2012, something happened that no scientist on Earth was fully ready for. A machine, billions of kilometers from home, hit an invisible wall that nobody even knew existed. For years, Voyager 1 had been traveling through quiet, empty-seeming space, far past every planet, far past anything humans had ever physically touched before. Then, in an instant, its instruments picked up a sudden change. The number of charged particles coming from the sun dropped sharply. At the very same moment, high-energy particles coming from deep in the galaxy spiked upward. This did not happen slowly. It did not fade in over weeks or months the way scientists expected. It happened fast, almost like the spacecraft had physically bumped into something solid, even though there was nothing there to touch. Voyager 1 had just crossed the Heliopause, the point where the sun's influence finally runs out and true interstellar space begins. Before this moment, most scientists believed this boundary would be soft and blurry, a slow fade from one kind of space into another. The data told a completely different story. The sun's protective bubble, called the heliosphere, ended sharply, almost like a real measurable wall, where energy from the sun collided directly with energy from the space between stars. In that single moment, Voyager 1 stopped being shaped by our sun's environment and became something shaped by the galaxy itself. For the first time in human history, something we built had physically pushed past the sun's reach. And crossing that invisible line revealed something even stranger. Interstellar space is not silent. It is not empty. From more than 24 billion kilometers away, Voyager 1 recorded a steady humming sound, sitting at a very low frequency, and that sound lasted for almost 3 years straight. Scientists described it as a thin, metallic tone, almost like the space between stars was quietly vibrating in the background the whole time. That sound turned out to be waves moving through interstellar plasma, the thin material that fills the space between stars. By studying it, scientists could actually measure how thick or thin that material was, turning a strange sound into a real scientific tool for mapping something completely invisible to the human eye. At the same time, Voyager's readings showed something that surprised almost everyone. The magnetic field out there in interstellar space was far stronger than any model had predicted, 2 to 3 times stronger, in fact, and it was pressing against our solar system's bubble with nearly 10 times more force than expected. That discovery means our entire solar system is sitting inside a bubble that is being squeezed and shaped by the galaxy around it, instead of just floating peacefully in open space like most people imagine. Now, fast forward to today. As of 2026, Voyager 1 is sitting around 25.5 billion kilometers from Earth, still moving outward at about 17 kilometers every single second. A signal now takes close to 23 hours to travel one way between the spacecraft and mission control here on Earth. That means sending one command and getting confirmation back takes almost 2 full days. On November 18th, 2026, Voyager 1 is expected to cross another historic milestone, becoming the first human-made object to sit a full light day away from Earth. A distance so large that light itself, the fastest thing that exists, needs an entire 24 hours just to cross it. But reaching that milestone is costing the spacecraft almost everything it has left. Its power source has been fading a little every single year since launch, and to survive this long, engineers have had to shut down instrument after instrument, one at a time, just to keep the spacecraft's heart beating for a little while longer. There is something almost impossible to picture happening right now. A machine humans built nearly 50 years ago is still awake, still working, still choosing which parts of itself to shut off just to keep breathing a little longer. Every single instrument NASA has turned off on Voyager 1 was not a random choice. Each one was a careful decision, made by real engineers, weighing what mattered most. The cameras went dark back in 1990, right after they captured one final famous picture looking back at our entire solar system. The plasma science instrument stopped working reliably by 2007. The instrument that studied ultraviolet light was switched off in 2016, long after most people expected it to fail. And the cuts have not stopped. NASA turned off the cosmic ray subsystem in February of 2025, and just a short while later, in early 2026, they turned off another instrument that measured low-energy particles. That leaves only 2 working science tools left on Voyager 1 today. One measures the magnetic field around the spacecraft. The other is the plasma wave subsystem, the exact instrument responsible for picking up that strange interstellar hum we talked about earlier. The person in charge of this mission at NASA has been honest about what these choices actually mean. Turning off a working science instrument is never something anyone wants to do, but right now it remains the only real option left to keep the spacecraft alive a little longer. Still, engineers are not simply letting Voyager 1 fade away quietly. They have been building an ambitious software fix, something they nicknamed internally as a way to squeeze more efficient performance out of this aging machine. If it works, it might even let some instruments that were already shut down come back online for short bursts of time. That kind of hope is unusual for a machine pushing 50 years old, running on hardware weaker than a basic calculator, sitting in temperatures close to absolute zero, constantly under threat from cosmic radiation that could damage whatever wiring still works. Every single watt of power left on Voyager 1 now has to be carefully split between 2 jobs. Keeping its heaters running, so delicate parts do not freeze and crack apart in the extreme cold of interstellar space, and keeping its last instruments powered up long enough to keep sending readings home. If engineers turn off too many heaters too soon, critical parts could fail completely. If they let too many instruments run too long, the spacecraft could run out of power years earlier than it needed to. Internal estimates from 2025 suggested that without extra power saving, Voyager 1 might have only had a handful of months of usable power left. With careful watt-by-watt rationing instead, the team now believes at least 1 instrument could keep working into the 2030s, stretching a 5-year mission almost 6 decades past its original plan. None of this is guaranteed, and mission leaders have never pretended otherwise. If the fuel lines inside either spacecraft ever freeze, their antennas could drift away from pointing at Earth, and the mission would end almost instantly, since there would be no way to send a signal back to a receiver that is no longer listening in the right direction. This is not the first time either spacecraft has come close to going silent for good. In November of 2023, Voyager 1 suddenly stopped sending back anything that made sense, just streams of broken, meaningless code. Engineers eventually traced the problem to a serious failure deep inside its data system. Instead of giving up, the team attempted something incredibly risky, rewriting decades-old code and moving it into whatever working memory remained, knowing every single command would take almost a full day just to arrive, and another full day before they would know if it worked. After days of total silence that stretched everyone's patience to the limit, Voyager 1 finally spoke again, in April of 2024, and engineers described it like hearing a heartbeat start up once more after everyone feared the worst. Long after Voyager 1's last instrument finally goes quiet, sometime probably in the 2030s if these power projections hold true, the spacecraft itself will not stop moving. It will keep drifting outward, carrying a small golden record along with it, a quiet message from a species that once looked up at the sky and decided to send a piece of themselves into the dark anyway.